In the circuit shown above, the current in the 2 ohm resistor is 2 amps. What is the current in the 3 ohm resistor? Okay, so the way that we'll approach this question is because we know the current in the 2 ohm resistor, we'll calculate the voltage across that resistor. So it's going to be V is equal to IR, Ohm's law. So V is going to be equal to 2 multiplied by 2, which is going to be 4 volts. Now, why is this helpful to us? Well, it's helpful because we can apply Kirchhoff's voltage rule, which is that the voltage, the sum of all the voltages around a loop has to equal 0. So if you go this way and you go down 4 volts, then if you go the other way around across here, you're going to go up 4 volts. And the bottom line of this is that this resistor also has a 4 volt drop. Okay, so we can calculate the current going through that resistor. So in that case, we'll use the same equation, but we'll rearrange to solve for current. I is equal to V divided by R, and that's going to be 4 divided by 4, because it's a 4 ohm resistor, and that's going to be 1 amp. Okay, so what we know now is that there is a 2 amp current going through this 2 ohm resistor, and then there's also a 1 amp current going through this 4 ohm resistor. And then we can apply Kirchhoff's current rule, which is basically saying that the sum of, or rather the current that goes into a node, which is one of these locations, okay, has to equal the sum of the currents coming out of that node. All right, so if this is 2 amps and this is 1 amp, to produce those two currents, you would have had to have a 3 amp current going into that node. So the current that's going through this 3 ohm resistor, since it's running around this circuit and it has to have actually entered this node here, must have been 3 amps. So B is the right answer.